Hello, Eric Larson here with a video about construction. It's February of 2025, coming to you from Silicon Valley, California. The first formality, Fusion is a trademark of Autodesk Incorporated. I use Fusion software to create my model for this effort. I've been volunteering for Habitat East Bay, Silicon Valley since 1998. I've seen a lot of construction errors and I've done a lot of rework. So I'm hoping that with some better planning, communication, and training, we can avoid some of those errors and move our projects along a little faster. I'm retired from computer engineering. Now I have some more time for volunteering since I'm no longer doing paid work. So I'm hoping that this video might have some wider applicability than to just our duplex building at the Sequoia Grove project. But maybe not. It's very specific to a specific building. So I made this video for the AmeriCorps. Previous versions or previous AmeriCorps members have reported that they felt like they really didn't have enough training to really lead construction efforts. I think they felt like they got shoved aside by the regular volunteers who kind of barged in and took over. So I'm hoping that with some better training in this video that the situation will be improved a little bit. So everything that I'm telling you is subordinate to the structural and architectural engineering plans. Nothing that I'm telling you should be taken as being taking precedence over those plans. There are a couple of exceptions to that. We'll go over that towards the end of the video. But the architect and engineering plans are what we have to follow. So I created a solid model using Autodesk Fusion software. It has the dimensions and placement of everything in the framing. And from that model, I was able to create some drawings. It has 33 drawings. They're readable at 8.5 by 11. You don't need a magnifying glass to read them, and you can put them on a clipboard. So you should be able to frame the building by consulting the drawings generated from the model itself, and the architecture plans. So what's good about this model is that we can turn on and off the visibility of various elements to visualize the sequence of assembly. This is the model. It shows a view of the building from the front. I've only done half of the building. The other half, the half on the right-hand side here, is is a mirror image. Hopefully that isn't too confusing. You can see the front door, the porch, the windows. You can see the foundation slab. You can see a few of the foundation anchors sticking up here out of the curb. This curb is also known as the stem wall. If we go around the building, we can kind of see the other aspects of it. This is a view of the sidewalls. You can see the windows. It's pretty easy. If we click here, we can see from the rear of the building. Zoom in a little bit. This opening here is where the stairway comes up. If we kind of orbit around, you can see the stairs coming up from the first floor. Okay, back in the slides. Okay, there's only a limited number of components to this whole building. The foundation is the first part of it. Party walls, the exterior walls, the stairway, the joists, the subfloor, and the roof. We'll go kind of into some amount of detail on each element of these things, and we'll try and present it in basically the order that you would use when you were building the building. So the foundation is the first thing that we have to think about. The foundation is 12 inches thick. It's steel reinforced. It's got rebar in it. The curb, which is also known as the stem wall, is 8 inches tall, 6 inches wide. It has cutouts for the doors. The foundation has anchor bolts placed into it before the concrete hardens, and if we place them according to the drawing, we can avoid interference with the studs. So let's take a quick look at the foundation and the anchor bolt. Okay, this is the foundation. You can see, I've turned off all the other parts of the building. If you see that, you can see that the anchor bolts are placed all the way around the foundation, and you can see that in some parts of the building the bolts are closer together than in other parts. And along the side wall, these anchor bolts, I think, are 36 inches apart, but they have to be much closer in areas of the building which take more stress, such as the front. And I haven't tried to perfectly mirror all the foundation anchor bolts on the other side of the building, but they should be a perfect mirror image of each other. And there's a cutout in the front of the building for the planter box, and there are cutouts for the doors in each case. And there's a very small cutout in the center where the party balls are. If there were moisture in the building, it could exit through this little opening here in the center. This is a drawing which explains the exact dimensions or placement of each of the foundation anchor bolts. If we arrow, it's kind of hard to see. This is one drawing where you might want to print it at a much larger scale, and you have the exact placement of each of the anchor bolts here, and you can see exactly where you would place them. You start at a specific point, you place them as you go along, and I'm not going to go into a lot of detail on this particular drawing, just because the foundations are being built by concrete contractors. They're going to place the foundation anchor bolts where they felt was correct. If you place the bolts exactly according to this drawing, you would find that there was no interference between the framing elements of the building and the anchor bolts. Now, you might encounter the fact that when you go to frame that the anchor bolts are in the wrong place for your framing. So what you got to do is one of two things. You cut the bolt away, and you simply put another bolt in a place that works, or in some cases you may be able to simply move your framing elements and simply put another stud on each side of where that bolt is. But that's something where you need to consult with your leadership. Consult with your site carpenters, such as Mike Huber or Jared Slaybaugh. They will tell you what to do. Anyway, not going to go into a lot of detail on this because the framing contractors have done it already. Okay, so there's three important dimensions about this foundation. Obviously, the overall slab has to be correct. It's 1 inch larger than the actual framing. The space between the party walls is very important, and we also are concerned about the width of the door openings in the curb. So we're using standard pre-hung doors, and so those walls, the openings in the curb, have to be wide enough to accommodate some door trimmers and our pre-hung door package. So a very important alignment in this building is the wall alignment with the curb, and we will take a look at detail 7 on structural drawing 6 to look at that in more detail. So this is structural drawing S6, and you can see it's just some very important details about different parts of the building. And we're going to zoom in on detail 7 here. This is detail 7, structural material slab at the exterior. I think SOG is slab on grade. And if we zoom in on it and look at it very carefully, what this is showing is that this is the foundation concrete. This is the stem wall here, and what you can see is this is how the hold downs are holding down the 2x6 wall. And the important thing to understand is that this 2x6 framing element, which is your bottom plate, should be aligned with the inside of that stem wall. And what that allows for is for the exterior sheathing, the OSB, to be flush with the exterior of the stem wall. And on the interior of the building, our sheetrock can extend down past the edge, past the edge, and come down to the floor. And it can come past the edge of this stem wall and come down closer to the floor. Another very important aspect of this particular drawing is to note that there is a 1/4 inch gap between the bottom of the OSB and the top of the stem wall. So this is probably one of the most important drawings of the whole structural series. Okay, we've talked about the wall alignment with the curb. Very important detail. Don't get it wrong. Okay, wall details. So I've designed as an example a very simple wall, which is not really real closely related to anything in our current building, but I think it's a good example, and I think it's very much worth talking about, just because the walls that we're building here at Sequoia Grove are not exactly identical to all the typical walls that you will see in the construction industry. Okay, so I'm gonna jump us into Fusion and take a look at that wall. Okay, here we are in Fusion. This is the generic wall, and this is about the simplest wall that you're ever going to build. This is the kind of wall that you would build for a 1-story building. It's the wall that you might build if you were building a wall for your own house and you were concerned about how much it costs. It's the wall that you would build if you want to make money in the construction industry. Okay, it's pretty simple, and you can see it's got 4x8 sheets. 1, 2, 3. These are straight sheets. It's got a window, got a door. If we pop open our browser here, we can turn off the visibility of these pieces of sheetrock or pieces of OSB. We have to go down to the bottom here to okay, hang on, okay, sorry about that little gap there. Yeah, anyway, what I've done is I've turned off the visibility of the sheet materials. You can see the underlying framing of this wall, which is pretty simple. And I have put double studs here in one portion of the wall, and that is definitely something that we will see at Sequoia Grove, because for our shear walls we have to have these double studs, which allow for a little easier and stronger construction. And here's our door opening. This portion of the wall is our door header. This is referred to as a cripple stud. This particular stud is a trimmer stud, a door trimmer. This stud is a king stud because it goes all the way to the top. This is a common stud. This is our window header. If we keep panning to the right, we will see this is a window sill. This is a cripple stud under the window. We have a king stud next to the window, and it's all pretty simple. If we look at the drawing, which would typically go along with a wall, you can see that I have labeled, or I've put the dimensions in for each where each stud should go. You start your layout from a single point on the wall, and you simply you can simply establish the position of each stud by these dimensions. Now, I didn't put them all in because the drawing gets really cluttered if you do that, but I think you can get the idea. I've labeled the pieces, the window header, the window rough opening, window sill, cripple stud, bottom plate, cap plate, top plate. We talked about this stuff already. So, and you can see that there are various critical dimensions here. Specifically, the length of the studs, which are 92 1/4, which is a standard stud, And you can see that this particular dimension is very important. It's where an adjoining top plate from a wall that is joining this wall perpendicular will fit. So this is a standard drawing for a wall. It's just an example. Now our walls that we are building at Sequoia Grove are different from this in that we do not have door headers because we're using a door package that provides that door header function. And similarly, we do not have window headers because our windows are aligned with the bottom of the top plate. So we don't have window headers or door headers, which is quite unusual. Okay, back to the slideshow. We talked about the various names of the studs, talked about door and window headers. There's an important concept which is that of being on layout. Now, when you lay out a wall, you want to ensure that your framing elements are such that a 4x8 sheet, the edge of a 4x8 sheet will land either in the middle of a stud so that you can have two studs butting together and each of them are nailed to the same stud, or they want to align with the edge of a stud if you have double studs, or you're on the end of the wall. So being on layout is a very important concept. And the same is true for your windows and your cripple studs. Okay, shear wall. Shear wall is extra strong, has extra nails to allow it to resist forces that deform the building, deform a wall. And a normal nailing pattern for a normal wall is you put a nail in every 6 inches around the outside of your OSB and every 12 inches on the interior of a wall. So a shear wall might have nails which are as close as 2 inches apart. So the second floor front wall is an example. And you might, if you need an extra strong shear wall, you might have OSB on both sides of the wall. So, a normal wall will have OSB on one side and sheetrock on the other. But if you need to be a super strong shear wall, you will have OSB on both sides of the wall. Now, I've never seen a wall like that in any building I've built, in the past 25 years. But our buildings at Sequoia Grove are called out to have OSB on both sides of the wall. So you can look at the first floor rear wall as an example. So we're going to take a look at the structural drawing sheet S1. And this is a very important drawing, so we're going to take a look at it. This is drawing S1 it's the first page of the structural drawings, and you can see that it has the foundation, the second floor, and the roof. And in this part of the drawing, you see the shear wall details. And we talked about looking at the first floor of the rear of the first floor, and what you'll see if you look very carefully at this wall is that it has these little triangles here with a 3 on each side. And so the question you might say is, well, what does that really mean? And so if we look at those 3s and we come over here to the shear wall schedule, and we see a wall here where we have a 3 on each side. And this is the strongest wall in the building. The edge nailing has to have 10-penny nails 3 inches apart, 3 inches on center on each side, and it has OSB on each side of the wall. And the bottom, which is going into the sill plate, also known as the bottom plate, you have 2 rows of SDS screws. These are Simpson strong drive screws, 1/4 inch diameter, 6 inches long, at 6 inches on center, staggered each row. So that's an enormously strong wall. You got nails 3 inches apart. You got a double row of screws at the bottom. The anchor bolts need to be 16 inches apart. So that's an amazingly strong wall. So let's take another look here on the second floor, and here we are on the front wall of the second floor, and if you arrow in, you'll see this this two inside of a triangle. So let's look at what the shear wall schedule says for a delta 2 wall, and here it is. And it says the edge nailing, you can have 10 penny nails, but they have to be 2 inches apart. That is 2 inches on center. So that's an awful lot of nails, and you better have your nail gun ready, or you'd have awfully sore arms trying to put in walls on 4x8 panels that are 2 inches apart. Okay, we've talked about shear walls. I'm going to take a pause just because I want to try and break this whole series up into three parts that are each about 20 minutes long. So I'm going to hit a pause, and we'll jump into the next video where we'll talk about our next subject. Okay?